In Unit 9, Part 2, we are looking at how to find the greatest common factor of two or more numbers. So a couple definitions for you. A common factor is a whole number that is a factor of two or more whole numbers. And then the greatest common factor, which is the worst definition ever, is the biggest of these factors. So the most self-explanatory definition that's ever. But again, we're looking at two or more numbers, and we're just looking for what they have in common. So in part 1, we did factor trees and prime factorization, because we'll need to use those same topics when we do the GCF. So you're going to want to start by making a factor tree for all the numbers that you're given. So 8, I'll break into 4 and 2. 4, I'll split into 2 and 2. Then I have my prime numbers there. So for 24, I'll split that into 12 and 2. 12, I'll split into 4 and 3. 4, I'll split into 2 and 2. And those are my factors. After you've done your factor tree, you're going to want to list out the factors for each one. So for 8, I have 3 2s. For 24, I have 3 2s and a 3. So once I've listed them out, I'm then going to circle the ones they have in common. So they have a 2 in common, 2 in common, and a 13. So the greatest common factor is then whatever I get when I multiply all of those together. So 2 times 2 is 8. So the GCF of 8 and 24 is 8. I'll leave number 2 for you. That one's actually pretty straightforward. And then for number 3, if you look, we can find the greatest common factor of more than just 2 numbers. So in this case, we're going to look at 3 different numbers. We're going to start with factor trees again. So 4 and 4, 2 and 2. And I can circle those because they're all prime. 32, I'm going to split into 8 and 4. And we'll work my way down from there. And then 40, I'm going to split into 10 and 4. And circle all my factors. Next step is then to write out the factors for each one. So for 16, I just have 4 2s. For 32, I have 5 2s. And for 40, I have 3 2s, 5. I don't want to circle everything they have in common. Now, to be the greatest common factor, or to be a common factor, all 3 numbers have to have it. So all 3 have this 2, all 3 have this 2, all 3 have this 2. Now, if you look, 16 and 32 share another 2, but I need all 3 numbers to have it for it to be part of the greatest common factor. So now I can multiply what they have in common. So 2 times 2 times 2, which is going to give me 8. And that's the greatest common factor. And I'm done with that. Number 4, I'll leave for you guys. Coming down to the next part, is identifying relatively prime numbers. So numbers are relatively prime if their GCF is 1. So they don't have anything in common except for 1. They don't both have to be prime, it's just that the only thing they have in common is 1. So the next part says, tell whether the numbers are relatively prime. So we're going to start the same way as we did before by doing factor trees of both. I'll do 12 and 2. Now, when I did the factor tree for 33, the only thing they have is 11 and 3. So if you look at the numbers that you circled, none of those are the same for 24 and for 33. So I know that these are relatively prime. If you wanted to, you could write them out and list them, but you don't have to. You can look right at them and see. Except I just lying on all of it. So Katie Palmer distracted me, and I didn't know what I was doing. I completely messed up. If you look, they both have a 3 in common. So since 3 is a factor, these are not relatively prime. Okay, it wasn't really Katie's one. Looking at number 2, I'm going to do the same thing. Factor tree for both. So 11 and 2 for 22, for 35, I'm going to do 7, 5. Now, if you look, I don't have anything in common, so yes, these two are relatively common. Alright, so if you look at the back side, this is when it gets a little bit trickier. We are looking at finding the greatest common factor of monomials. So we factored out monomials in part 1. We've just done greatest common factors 2 seconds ago, so now we're going to apply it to the monomials. So we're going to start the same way we've been starting all of this. We're going to do factor trees with the number parts. So 32, I can split into 16 and 2. That'll split into 4 and 4. 2 and 2 for both of those. I'll wind up with 5, 2. Need to break down 20 as well. 20 becomes 4 and 5. 2 and 2. Again, just a reminder, for 32 I could have done 8 and 4. For 20 I could have done 2 and 10. I would have wound up the same place either way. Now the next step, which is even more important now that you have variables, is you're going to write out your original and then do the factoring for it right now. So for 32 I have 5 2's, and then I have an x and a y. And obviously I'm flooding over into the other problem, don't worry about that. Then for 20y squared, I have 2 2's, a 5, and 2 y's from the y squared. So now I need to circle what they have in common. So they have a 2 in common, they have another 2 in common, and they have a y in common. So my greatest common factor is then 2 times 2 times y, which is 4y. So my GCF is 4y for this. I'll let you guys do number 2. I'm going to come down here and look at number 3. So number 3, we're going to do the same thing we've always done. We're going to start by factoring out the number parts. Now I'll tell you a shortcut when we get to the end of this one, but just for practice sake, I'm going to factor out the numbers. Now if you look, when I get to the third one, so this is kind of hard to read, my first one, my second one, my third one, I don't have a number part. So in retrospect, I really didn't need to factor these down because they're not going to have anything in common if there's no part to them. So what I can do is just write out r, s, and t to the third, r squared, s to the third, t to the second, and r, t to the fifth. Now, you could write out all the variable parts and then circle them, so like r, s, t, 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 and then work them all out. Or a shortcut way is just look at them. First, you need to make sure they have them in common. They do all have an r in common, and then for greatest common factor, we take the lowest power. Meaning, if you look at the r's, I have an r squared, and another r. So I take the lower one, which is r to the first. Then I look at the s's. I have an s to the third, and then no s. So I know that cannot be part of it. So they don't have an s in common. And then looking at the t's, I have t to the third, t squared, and t to the fifth. So again, I'm going to take the lowest one, which would be t squared. So my greatest common factor for all of this would just be rt squared. They don't all three have a number part, so obviously they don't have anything in common. They don't all have an s, so it's just the r's and the t's they have in common. Okay. Looking over here at number 4, since they do all have number parts, it's going to be a little bit more work. So we'll start by factoring those out. So 9 splits to 3 and 3. 18 is going to be 6 and 3. 3 and 2. And then 6 is just going to be 3 and 2. Now, since these all have number parts, it's going to be a lot more important to write out what they have. So I'm going to have 3 times 3. I have an x, 2 y's, and a z. So 18 y to the third. I have a 2. I have 2 3's, and I have 3 y. And then for 6x, I have a 2, a 3, and an x. So remember, when we have 3 things and we're finding the greatest common factor, all 3 have to have in common for it to work. So if you look, 9x y squared z does not have any 2, so those 2's don't matter. They all have this 3 in common, but that's it from the number part, okay? 9 and 18 have another 3, but 6 doesn't. Then if you look at all the variables, there isn't a single variable that they all have. So 9 and 18 both have y's, but 6x doesn't. Okay, 6x has an x, 9x, y squared z has an x, but the middle one doesn't. So out of all of that, the greatest common factor is just 3, because that's the only thing they all have in common. Alright, I know this is probably a tough part, so make sure you ask me any questions you have. Lots of review problems down here for you, make sure you get those done.